So in this video, we'll look at the volume of certain solid generated by rotating this shaded region along certain axes. And obviously, the volume formula depends on the axis we choose. And the method we learned in the last couple of videos is basically called the method of Washer. And let's look at the following problem. So as a warm-up in the part A, let's look at the volume formula of the solid. Now the solid is obtained by rotating the region along the x-axis. And please think about the kind of solid that you're getting. You see, if you try to rotate along the x-axis, and basically you're basically getting a solid like this, I think. So I'm trying to quickly sketch a picture about the solid we are getting, you see. And this is the x-axis we rotate. And you see the point is that there's a big empty part in the middle. And this part, like the last couple of videos, we basically call it the inner solid, which needs to be cut out from the whole solid in purple, which is called the outer solid. And now, basically by the washer method, and the formula should be something like the volume formula for the outer solid minus the volume formula for the inner solid, right? So basically, and also because it's an x-axis rotation, so it should be a dx integration. So please ask yourself as a first step, how to find the AB? Because now we are doing the x integration and we are going along the x-axis for AB, so A should be the leftmost point and B should be the rightmost point. And I think in this case, B is obvious because B is simply the x-coordinate standing along the line x equals 8, so B must be 8 as the x-coordinate of any point on this line. And for the A, which is the leftmost point, you see this point. Please read this point extremely carefully. Essentially, is the x-coordinate of the point, which is the intersection of the two lines, y equals 2x plus 1, and the second line, y equals 3. So you have to solve it mathematically. So 2x plus 1 equals 3. I make them equal, so it means x is basically 1, right? So it means actually A is 1. A is actually 1. So let me put the answer here. So basically, you see now the formula, you're just missing the outer radius and the inner radius, right? And it depends on your understanding of the solid on the left-hand side here. And basically, the outer solid is the solid generated by using the outer line of the whole thing. And let's look at this line again. This line, by the function, it is y equals to x plus 1. So essentially, the radius, which is the outer radius for this solid, is based on the radius of a disk like this, and the radius, which is basically the y length of this point on this curve. The y length is basically the y coordinate, which means I can just simply use the function 2x plus 1 as the outer radius. And then similarly, the inner radius is the red part that you need to cut out from the purple part, which is something like that, based on my previous picture here. And for such kind of figure, and this line, we knew it from above, is that the equation of this line is y equals 1. So basically, that's the radius, which is fixed at 1 because now the line is horizontal, right? And so it means basically the circular disk always has a fixed radius 1 and is a constant radius for all the inner circle because of the fact that this one is actually a regular cylinder, right? So basically, I just leave the inner radius as 1 here. And essentially, that's the answer to this problem because I'm just asking for the volume formula, and you just have to state the formula here. And I trust that you're able to do this numerical computation on your own. And let's come to a next problem, and we'll try to find the volume formula of another solid based on the same picture, but we use another axis. So excuse me, I would like to make a correction here. This one should be 3 because based on my picture above, this line is actually y equals 3. And excuse me for my mistake, and we'll go to the next part, part B. Now please look at the current problem, and you see the axis. Although we are having the same picture as before in part B here, so but the axis is pushed downward from the x-axis by 3 units. So basically, I use a red color to represent the axis you have, which is y equals minus 3 here. And please tell me the corresponding volume formula in this case for the solid that you're getting. And I think the calculation is quite similar to the last part, part A, because of the fact that our axis is actually in the same direction as the x-axis. Both lines are parallel. But it's just because the fact is that you see the outer radius based on the use of this outer line, which is y equals 2x plus 1. The outer radius is actually extended by 3 units because our axis is pushed downward by 3 units, right? So basically, if you try to use the washer method again, you have to write down the outer radius, and the outer radius we have to add 3 to the original length of the outer radius, which is based on this function, which is y equals 2x plus 1, right? So basically, I add 2x plus 1 here. This is based on the outer line, which is y equals 2x plus 1. And similarly, for the inner radius here, which is based on the, so I use the green line to represent that. It is actually now based on this inner line up to the rotation axis, right? So you see, you have to add 3 to the original length of the inner radius, which is of course 3 because of this line y equals 3, right? So basically, I'm saying that you have to use the inner function, which is y equals 3, and you have to add 3 to the radius of the inner solid also. Of course, it's still a dx integration, and the lower and upper limit AB here are the same as before, which are 1 and 8. And let's look at other kind of problems from here if you're okay with that. So now please look at the current problem. I'm once again giving you the same picture, but I changed the axis now to the y-axis rotation. So please check that you're basically rotating like this. And now you have to change the perspective completely, because if you're trying to use the washer method, so let me write down the formula first. Now for the y-axis rotation, the AB here, you're going along the y-axis because of the fact that you're measuring the inner and outer radius horizontally now, because the cross-sectional area is basically now a circular disc which is cutting exactly across the y-axis like this. So this is the outer radius we look at. So I'm talking about this as the outer radius now. It will generate the whole cylinder like this. That's like the first step. So and anyway, I'm basically saying that it's a dy integration now. So mathematically speaking, you have to give me a y expression for the outer and inner radius. And now let's look at the outer radius. I put it here. You see, this outer radius is based on the length from the y-axis up to this line. And this line is what? This line previously, I talked about it already, is x equals 8. And this length, of course, is constant at 8, right? Because you can see this length never change wherever you draw the outer radius. So it should be 8. And how about the inner radius? The inner radius corresponds to the inner solid that you need to cut out from the whole horizontal cylinder. You see, this is the horizontal cylinder that you need to cut out from the red outer solid. Now you see, you have to cut it out here basically. So I'm saying that you have to cut out this part, and it is of course based on the inner line. The inner line is y equals 2x plus 1, and I've told you already. Well, first of all, if you look at this inner radius, you see this one is the inner radius. It is the horizontal x length of this point. This point is standing on this line y equals 2x plus 1. So the x length is what? You have to mathematically transform this equation into x equals y minus 1 over 2, right? And that's basically the expression I need here, which is x equals y minus 1 over 2. And the last bit of this problem to fix the formula is that you have to tell me what is a and b. And AB along the y-axis, because we're doing the y integration, should be the lowest point A up to the highest point B. And A in this case is just the height, based on the line y equals 3. So A must be 3. How about B? B, please trace it back on this point. The B is based on the y coordinate of this point, which is the intersection of two lines. The lines are y equals 2x plus 1, and the line x equals 8. And we can replace x equals 8 up here. So it means that y equals 2 times 8 plus 1, which is 17. So this is the y value of this point. So it is actually b, right? So it means b is actually 17. So it means we'll state our formula here. So basically the formula is the integration of dy from 3 to 17 for pi 8 square minus pi, open bracket, y minus 1 over 2, close bracket square. And that's the end to this part. And let's look at more part from here. So please look at the current case. Now it's like I pushed the vertical axis of rotation to the left side by 1 unit. So now the rotation axis is x equals minus 1. And I would like to ask you to tell me the volume formula again based on the method of washer, and that's the method we learned, right? So now please imagine what kind of solid you're getting. I think still the same thing as the part 3. We're getting kind of a solid like this, and based on the axis, you see, based on the axis, which is x equals minus 1, right? And once again, same as the last bit, we have to cut out a big empty part inside. And let's check out what is the meaning of the outer radius. But before that, let's write down the base of the formula. And because the axis is actually parallel to the y-axis, so conceptually it's similar to the last part. We have to use the y integration from a to b. And if you recall, what are the a to b? And actually the a is 3. And the b is actually 17. And we have found it already. So and then let's look at the meaning of the outer radius here. So the outer radius here is of course based on this line, right? So this line I'm saying, because that's the way you generate the whole circular disc like this. So this length based on this two-dimensional picture is basically this length, which is the outer radius in green color. And this length is basically the same as this length, which is of course based on this line x equals 8. So this length is 8. You have to add 1 to that. This one is simply because of the fact that this distance that is extended from the original outer radius of the last part. You have to add 1 to the outer radius from last part. So the answer is 8 plus 1. This comes from the fact that the line we look at is x equals 8 for the outer line. And then similarly, you have to tell me what is the inner radius here. And let me use another color to represent that. So you can look at the red part here. That is the inner solid that you need to cut out. And you can see this is the inner circular disc. And you can look at the meaning of the inner radius. The inner radius is something like that, right? Basically the same as this, the inner radius. And this inner radius is once again quite similar to part C, but we have to add 1 to this length. And this length from last bit, we got it already, is based on this line. This line is y equals 2x plus 1. We have to transform it back to x equals y minus 1 over 2, right? So basically, let's put the answer down in the purple color back here. So you have to add 1 to the x expression of this line, which is the inner function to generate the inner solid, right? Y minus 1 over 2 here. And that's basically the end to this volume formula. And let's look at maybe 2 more cases. Please look at the current part D. I'm once again giving you the same picture, but I changed the axis of rotation to x equals 10. So if you rotate along this axis, you're definitely getting a different solid, because I expect that after the rotation by 360 degrees, we're actually getting a solid like this. And you see, once again, you have a big empty part that you need to cut out for this solid, right? And I hope my drawing is not too bad and you can somehow kind of understand my drawing. So anyway, I'm using the method of washer again. You have to analyze the picture more carefully. But before that, you have to tell me something like that. That is the washer method. And you have to tell me whether it's a x or y integration. It must be a y integration. Why? Because basically you're counting the disk, like from the lowest point to the upper point, because a disk is always a cross-sectional area, cutting along the axis of rotation. And the axis now is parallel to the y-axis. So we're counting the circular disk from the lowest point to the upper point. So the answer to A and B must be the same as part C and D. And we got that already, which is 3 here, and it is 17 here. And let's look at the meaning of the outer radius. The outer radius means you have to use this line, and you have to use this line basically to rotate along this axis, x equals 10. Basically, I'm talking about this line. When you rotate along this axis, you get the outer solid, right? And it means the outer radius is here. That is the radius of this kind of disk. I hope you kind of get my point. It's the outer radius of this kind of disk. So anyway, let's come back here. How to measure the length of this line? The fact is that you can measure it as follows. You see this line? This length is actually fixed. This length is what? This length is constant at 10, right? And you use this length 10 minus what you have on this part. And this part is clear because this part is the length from this point, which has the x-coordinate 0 up to the x-coordinate of this point as, and we have mentioned already the x-coordinate of this point is basically based on the use of this curve, which is x equals y minus 1 over 2, right? So basically I'm saying that the outer radius, you can think of it as 10, which is the black length on this picture, minus the purple length, which is y minus 1 over 2. So I can put it here. It's 10 minus y minus 1 over 2. That's the outer radius. How about the inner radius? Maybe I change to another color, which is green. You see the inner radius is actually based on this circular cylinder that you want to cut out, right? And if you look at a disk like this, and I think it's clear that if you come back to this graph, the empty part has this length as the inner radius. And this inner radius, I think, is a fixed length because we are getting a green vertically placed cylinder. And this length is between the two lines x equals 8 and x equals 10, you see? So it means the length is 2. And this one is actually fixed. So I've just put the inner radius as 2. The other way to think about the 2 is that you can use the whole length 10 minus this length, which is 8, right? So it's essentially 10 minus 8. You can think of it as the inner radius as 10 minus 8. And that's basically the volume formula for this case. And look, so please look at the current part now. And I changed the axis again to the line y equals 20. You see, that's the line here we have. And you are rotating this region along this line. So can you imagine what kind of figure you're getting? So basically, I'm getting a picture like this. So please look at the current picture. We expect that we're getting a solid something like that if we try to rotate the region along the line y equals 20. And now, once again, we are using the washer method. So let's try to write down something here. Once again, it's the outer solid minus the inner solid in terms of the formula. And because now you see this axis is parallel to the x-axis. And if you look at the circular disk you form, which is a cross-sectional area like this, you see, and every time you're measuring such a disk, based on a radius like this, and the radius is based on a certain marking on the x-axis, so it makes sense that it must be the x integration from the leftmost point to the rightmost point. And we have done it actually in the part A and B, and actually the leftmost point, of course, is 8. The rightmost point, I'm sorry, and the leftmost point is actually 1, and we have done it already. So let's look at the meaning of the outer radius. The outer radius is, of course, same as my picture, which is the outer radius in green color. And this radius is basically what? It's basically this radius based on this current picture. And this radius, how can we write it down? And I think it's not very difficult because it's like this length, which is the vertical length based on this line, right, which is the axis of rotation, it is 20. You have the 20, you have to minus this part, and this part is the vertical length based on this line, which is 3. So basically, it's kind of like the outer radius is 20 minus 3, which is, of course, the same as the constant 17. I will just put it here. And similarly, let's check out the inner solid. The inner solid is a solid that you need to cut out from the big solid here. You see this part is empty, right? And you have to cut it out. And this kind of circular disk is something like that. And based on this picture, you see this part is basically the inner radius. And let's come back to the two-dimensional case. This the green radius is basically this kind of line, right? It is from the axis of rotation up to this line, basically. And this line is y equals 2x plus 1. So what is the green length? And once again, we can look at the whole length, which is 20, minus this length. This length is what? This length is the length from the x-axis up to this line, which is of course measured by the y-coordinate, which is y equals 2x plus 1, because it's the vertical length, which is the y-coordinate, right? and this length is measured by 2x plus 1, which means that the inner radius, we can think of it as 20 minus the function 2x plus 1. So I just put it inside the inner radius, inside the second bracket. So it's 20 minus open bracket 2x plus 1 close bracket, and that's basically the end to this part.